All right, so we're now going to look at what it takes to figure out how to calculate the empirical formula of a substance when it contains two or more elements in that compound or molecule. Now, be mindful, the empirical formula is the one that shows the lowest number or lowest ratio of atoms or ions in the compound or molecule. So it's the lowest ratio, the lowest number of subscripts you can have. All right, so it's not the true chemical formula, it's the lowest ratio of atoms in a compound. All right, so be mindful, we're looking for that low ratio formula. So what we have here is we want to look for the empirical formula for a compound that contains three elements. We're looking at carbon, we're looking at hydrogen, and we're looking at oxygen, all right? Now, you're given, in this case, we're not given mass information, we're given percents information, basically percent composition. So those percents represent the percent composition of those elements in this compound. We're looking for the empirical formula of this compound, all right? So what we're going to do is we're going to use the percent composition to figure out what's that lowest ratio formula for this particular compound, all right? So I'm going to line up my elements just like in the order that they're listed. I'm going to take my percent composition. So we're going to do, this is one of those ones where you have to do 4 steps. Remember, it's a 4-step to do empirical formulas. So the first step is I'm going to take the percent composition, I'm going to list them all, 6.7, 53.3%, and I need to get masses. I need to turn them into masses. Well, guess what? This is the easiest one you're going to do. You're going to take that percent composition, turn it into its decimal form. So here we go. And that automatically becomes grams. We're just going to make it grams because it really represents how much of something you have in a compound. All right, so we're just going to convert our percent composition to grams. All right, easy peasy. All right, so now that we have our grams information, remember, this is where we're going to use some of our newly learned molar conversion work. All right, so I'm given grams here. And that's this right here. That's step 1. Step 1. All right. Step 2 is we're going to do a molar conversion. So we're going to go from grams to moles for each one of these set of grams. All right. And remember, looking at your card, or remember the work that we did, to go from grams to moles, we divide by these elements individual molar mass. So these grams, to turn them into moles, we're going to divide by his molar mass. So for carbon, it's 12.01 grams per mole. For hydrogen, it's 1.008 grams per mole. For oxygen, it's a good old simple 16 grams per mole. Okay? So once you get that, we're going to turn it into moles. Now, this is important. Don't round your moles. We save rounding to the very end when we're counting up our significant figures. So I'm going to give you my crazy big number of moles once we've calculated out. So in this case, carbon's going to equal 0.033305579 moles, right? Hydrogen is going to equal 0.0646824 moles. Now, oxygen, this particular grams to moles, is going to equal 0.0333125 moles. So that was step 2, convert to moles. We want these moles, all right? Step 3 is we have to look at the moles that you've calculated, and you have to pick the lowest, we want the lowest number of moles. all right? You want to pick out the lowest number of moles. So it's definitely not him, he's the biggest one. It's between these two guys. And I'm going to look at him. So it's 0.0333, 0.0331. He's our winner. All right, so he's the one we're going to pick and use to divide all of them by. We're going to divide everybody by the lowest number of moles. Okay? So take that number and divide by the lowest number of moles. All right? 1, 2, 5. So this guy's going to be easy. Remember, our goal is to get a whole number. Our goal is to get a whole number. Okay? So this one's easy because that one, this divided by the same thing equals 1. So that one's done. All right? We divide this one by this one. He ends up giving me 1.99, which is nice because I can easily, without having any conflict in my heart, can round it to 2. And then finally, this guy to this guy, honestly, you can't get any closer to a 1. So he too all comes out to as close to a 1 as well. So here we got our whole numbers, 1, 2, and 1. We're going to use those as our subscripts, all right? So step 3 is do that division. And step 4 is to take those whole numbers, take these whole numbers. We're going to come back over here and look at our elements and put them in the same order, C, H, and O. All right, so C, H, and O is my compound. C, H, and O are the elements that make up this compound. Come over here for step 4, look at my whole number answers, 1, 2, and 1. So the ratio of these elements in this compound is 1 to 2 to 1. That, ladies and gentlemen, is how you calculate the empirical formula of this compound that contains this percent oxygen, that percent carbon, that percent hydrogen, that percent oxygen.